Hi everyone, so I wanted to make a video to show you how to use tinkercad and build circuits so that you all do well on the lab midterm retake. So starting off, I'll introduce the breadboard. You'll see that I have drew red, black, and green lines here. Now this is to show you that these holes are all connected as one node. So row 22 A through E are all connected as one node. Anything that you plug into, let's say 22D, it will automatically be connected to 22A. So the same goes for the positive and negative strips. If you connect the power supply to the positive end here, you can get power by connecting a component to the positive end here. Now, of course, you also need to connect it to the negative end here and something else connected to the negative end here to close the circuit. So what does that mean for a basic circuit? Now, let's take a look at lab 1. The first one just asks you to measure the resistance, and how you can do that is simply just by connecting a multimeter to the resistor, to the two ends of the resistor, and you'll be able to read their resistance. So you'll see that this one has, I accidentally left it on voltage, but now it's reading a resistance. And this power supply, we haven't done anything with it yet. So let's start building a circuit with this power supply. You'll notice that I have a positive, the positive end of the power supply plugged into the positive bus strip. And you'll see that when I hover my mouse over here, all the other holes in the positive bus strip are circled in green. That means that if I connect here, it's going to be connected to all and connected here. Oops, sorry about that. Let me connect this again. Let's say I connected to here. That means that this wire is already connected to this wire. All right, so because these are all connected to a single node. These are a single node, and anytime you see other green holes like this, that means that they are all part of one node. So that's pretty helpful, because we can go over here now and we see that this resistor is connected, the other end of this resistor is connected to this terminal 2. All right, so we can click on here and you'll see that there's a green circle around the other end of the resistor. That means that if we make a connection, it's going to be connected to that end of the resistor. Pretty helpful. Let's just take this and we can drag it over here. Do you see the green circles light up, and it's circled around the black wire connected to the power supply. So we know that this connection will be in the same node as the power supply, and we can go ahead and put black here and red here, or whatever system you're comfortable with. Now, this is going to have you'll see that this has a current of 5 milliamps running through it, and if we just adjust the resistance on this, let's raise it up to 2 kilo ohms, you'll see that this should now say 2.5 milliamps because of a higher resistance, and it sure does. All right, so that's how you build at least one resistor into a circuit with a power supply. What about if you have, well, okay, hold on. First we need to get the voltage, right? Let's take another multimeter and bring it out. Here we go. Now you'll see that sometimes people might do stuff like this. I don't really particularly like that because it's not realistic, and you'll see why if you get a real multimeter. You can't just plug it into the breadboard. So I'm going to measure the voltage, you'll need to connect the multimeter in parallel with the resistor. What that means is that one end of the multimeter must be connected to one end of the resistor and you'll see that there's green circles around the black cable and the end of the resistor. So there's that, and then this will connect over here. You'll see the green circles light up, Great. Now this is connected in parallel because, um, well, we have one end in the same node as the end of the resistor and the other end in the same node as the other end of the resistor. So let's take the voltage across this resistor, and it's showing as 5 volts. Okay, now does that make sense? Well, let's see. I think it does because the power supply is giving uh, a voltage of 5 volts, and that this resistor is the only component of this circuit. So it makes sense that the voltage across this resistor would be equal to the voltage across the power supply. Alright, great. Now we need to measure the amperage. So we need to measure the current. To measure the current, you're going to need to put the multimeter in series with the resistor. So very simply, all you need to do is open up the circuit. So I'll delete this cable. Now, we need to close the circuit somehow, right? So we need to connect this negative end of the resistor. Well, we can connect it to the negative end of here, right? So now and then, hold on, oops. Well, it doesn't really matter. We could just connect it here like this. And let's set this to amperage. And it's a negative number because, well, the signs are flipped. So we really need to, it doesn't really matter. You could just flip it yourself when you write down your answers. But let's connect the black wire to ground and the positive end to here. And let's see if this works. Oh, look at that, it works. So this is measuring current because let's think about where the charge is flowing. So positive charge at least. So it goes through here, it goes through the resistor, it comes to the multimeter, and then it comes back down. It's one single loop, which is how we can measure current. And let's, so we could easily do this with present knowledge. And let's see if there's anything else for the first lab. Okay, so how do we build? Now we're looking at resistors in series. All right, let's do that. So when you have more than one resistor, this is what I like to do. Here we go. So I just like to separate them by distances of 5. It keeps them organized. I start at 5, go to 10, 15. It's not anything significant, but just space out your components and your life will be so much easier. So we have 500 ohms, 2 kilo ohms, 5.1 kilo ohms. Let's do that. This is 2 kilo ohms, and this 500? Yes. Okay, great. So how do we connect these in series? Well, let's just go around the circuit. Let's see. So we are measuring, what do we need to measure? We need to measure the voltage. All right, so first 500, 2 kilo ohms, and then 5.1 kilo ohms. So let's connect. So for me, I like to think of the left side as the positive and the right side as the negative end. So what that means is that while I'm building the circuit, I'll connect the positive to the positive. I'll leave it at green. The negative to the positive because they're in series, and if you add the symbols onto the if you add them to the circuit diagram, it might help you keep track of which nodes are connected to which. And this is the negative, so it goes to ground. Here we go. And I'll label that as black, and I'll label this as red. And you'll see that this is 658 microamps, which is significantly lower than what we've had before with 5 volts and just a single resistor. And I think we need to change this to 15 volts. So let's change that to 15 volts. and measure the resistance. Now we need to measure the resistance starting from before R1 and ending after R3. So very simple. All we need to do, same as before, take out the multimeter. All right. So let's do the positive end to before. So this is, remember, this is the positive side, or as I like to reference it, the positive side of a resistor. So I'll label that as red for positive, and the circuit goes here, resistor 2, resistor 3. Aha, here is the node after well, this is the other end of the resistor 3. This is the negative end. So I connect this here. And we are measuring what? Voltage, right? So we're measuring voltage. So you'll see that we get 15 volts, which is what we should be getting if we are measuring this correctly. All right. Now we need to measure amperage. Okay, not too difficult. Let's take these wires out, move this to this side so we have some room to work with. So all we need to do is splice in the multimeter into the circuit. So right now the circuit goes here, here, and then it goes around the different resistors and it comes back. I want to put this right before the first resistor to measure the current. So I'm going to delete this wire that connects the first resistor to the power supply. And I'm instead going to connect it to the multimeter, and the positive to positive, negative to, well, I guess this time it would be negative to positive, but actually let's see what we get in terms of amperage. Alright, so we are getting 1.97 milliamps, which makes sense for a circuit in series because it's the same current across all three resistors. Now, what about a circuit in parallel? So how do we build a circuit in parallel? Well, it's just like a circuit in series. The only difference really is that let's delete all these wires first. So let's look at the nodes in this circuit, right? How many nodes do we have? We really only have two. We have this one on top, and this one on the bottom. All right, so makes sense. Let's start by visualizing what happens when we go here. Okay, well, it goes to one end of resistor 1, one end of resistor 2, another end of the resistor 3. So that means that we could connect from the positive node to one end of resistor 1, one end of resistor 2, one end of resistor 3, right? Because they're all connected to the positive side of the power supply. All right, pretty cool. So, well, it looks like the other ends are connected to the negative side of the power supply. All you can do, well, all you need to do really, is remove this wire, take it, put it into this side. Oops. It doesn't really matter where you plug it. You could even plug this into the positive side. It won't make a difference, but just for just to be consistent, we're going to plug this into the negative side, and here. Here we go. So now these resistors are all in parallel, and this setup might look funky, but it just goes to show you that there are many ways to make a circuit on Tinkercad. So now we have 40.4 milliamps. Let's see if that makes sense. Well, I think it does. Well, and let's see. We have to take the voltage across R3. Now remember that resistors in parallel have the same voltage. So we should expect the same results across R1, R2, R3. Well, let's look at where the voltmeter is being placed. Top of R3, bottom of R3. Alright, not too hard. So I will connect the negative side to the negative side of R3, set that as black, positive side to the positive side of R3, set that as red, and we are measuring the voltage. Let's see what we get. 15 volts. I think that makes sense. And let's, just for fun, see if we get the same results if we connect them to the other resistors. Here we go. $15 volts, that's right, and it should be the same if we connect it to the first resistor too. You could try this out for yourself, but I'm not going to. Now, measuring VR13 correctly, yes, we did that. Now we need to measure the amps. How many amps is going through the current? So let's look at where we place the amp meter. We place it right before it splits off into R1, R2, R3. Okay, so what does that mean? Well, we need one end to connect to the positive end of the power supply. So let's take this out. Positive to positive. There we go. And oh, it's hiding, so I'll bring that out. Negative to this end of the positive. Now I'm only doing this because, well, we want the current to go through the multimeter and then go to here, which is connected to all the other resistors. Let's set this to amperage and see what we get. 40.4 milliamps, which makes sense, I think, because that's the total current going through the circuit. Okay, I think that's all for the first lab, so I will let's move on to the second lab.